Hey everyone, in this lesson, it's a really brief lesson, we're going to be just talking about how to graph with tables and how to come up with equations of lines given either an equation or given AH and K or given a graph. So for our first problem here, you should notice y equals 2, x minus 1 cubed. That is a cubic. So really quickly, I'm going to graph my parent function, cubic. Remember, it's y equals a, x minus h cubed plus k is what we learned last class. So 0, 0 is definitely a point on my graph because 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, which happens to go off of my graph, but on the sheet provided, it will be on your graph. Negative 1 cubed is negative 1, negative 2 cubed is negative 8. So there's my original parent. Sorry for this little jag there. Didn't mean for that to happen. So now let's talk about our transform function. So if you look at this equation, your a is 2, which means you're going to open the same as your parent function. It's not going to flip. I don't know why it's not letting me write my e and n for a moment, but opens the same direction, and it will be steeper, or you could use the words narrower. Hold on. Sorry, I was making a video after school, and that's what happens. You get random announcements. So anyway, it's steeper. You could also say narrower, skinnier. All of those are good words. Stretched. Okay, so my h is positive 1, even though it's a minus sign. Remember, your parent function, it should have a minus to be positive, and that's going to move it to the right. And then k, there's nothing there. It's 0, so there's no vertical change. Okay, no vertical shift. All right, so let's graph this. So where you need to shift to the right 1 unit, we're going to shift 0, 0, right 1 unit. Okay, and that's going to go in the center of our graph. So 1, 0, it's going to go in the center of my table. All right, and then we're just going to pick points, and we can pick any points that we want, but I like to pick points that go in order. So notice I picked negative 1, 0, 2, and 3. We're going to now take that number and we're going to plug it in to our function for x. So if we go back to this original function right here, we're plugging in negative 1. We would subtract 1 to get negative 2, and then we would cube it, following order of operations, to get negative 8. And then we'd multiply by 2 to get a total of negative 16. Notice that will be way off my graph, farther than I can even show you right now. Then 0, 0 minus 1 is negative 1. Negative 1 cubed is negative 1 times 2 is negative 2. So 0, negative 2 does fit on my graph. If we plug in positive 2, well, 2 minus 1 is 1. 1 cubed is 1, and 1 times 2 is 2. So 2, 2 is also on my graph. And then 3 minus 1 is 2. 2 cubed is 8. 8 times 2 is 16, which is way off my graph. So you notice it is a lot steeper than our initial graph, and it is shifted to the right 2 units. Here's our next problem. So you should notice right away when you see this equation, it is an absolute value equation. All right, and so absolute values, here's the initial parent function. It's this perfect V that goes across all our wonderful diagonals with the bottom of the V at 0, 0. Now in this transformed function, my a is 1, my h is negative 2 because of the plus sign, minus a negative becomes plus, and my k is negative 5. So my a being 1 means we're actually going to open the same as our parent. So open same, meaning it's still an upward facing V. And because it's just 1, there's no width change. Even if it was negative 1, there'd be no width change. When is there a width change? 1/2, 5, negative 4, negative 2/3. Those would all give me some form of width change. Okay, so negative 2 means we're moving to the left for h, and then down 5. So I move to the left 2, down 5. There's the bottom point of my V. And then we're going to pick some points. So negative 3, negative 4, negative 1, 0. Now we're just plugging in. So negative 4 plus 2 is negative 2. Absolute value is 2. And 2 minus 5 is negative 3. So negative 4, negative 3. Plug in negative 3. Negative 3 plus 2 is negative 1. Absolute value is 1. Minus 5 is negative 4. And then negative 1 plus 2 is 1. Absolute value 1 is 1. Minus 5 is negative 4. I hope you're seeing a pattern here. And then 0 plus 2 is 2. Absolute value is 2. Minus 5 is negative 3. Notice that's exactly what we expected. There's no width change. It's still an upward facing V. And that's how you graph with tables. All right, so now if you flip to the back of the note sheet that I provided, you should notice that I'm asking you for a given the parent function. Well, I have to actually give you one for that. So our first given parent function is going to be y equals a log of x minus h plus k. That's our logarithmic parent function. So if I tell you that a is -2, h is 3, and k is -2, we're just going to plug those in. So y equals -2 log of x minus 3 minus 2. There's my equation. If I tell you your parent function is y equals a x minus h squared plus k, that's a quadratic. So again, all we're doing is putting our a, our h, and our k into their proper positions, and my equation would be y equals -1/3 x plus 4 squared. I don't have to write plus or minus 0. It's fine the way it is. Now, if I have a graph and I want to come up with an equation, I'm going to look at the graph and I'm going to see what shape it is. Now, this particular graph should technically have an arrow right here and a starting point right here. You should recognize that as your square root. So a square root equation is y equals a square root of x minus h plus k. Normally, our square root looks like this, a normal upward facing eyebrow. Notice that we have shifted to the left and we've shifted down. The eyebrow has not flipped, and we don't know how to find what number a is right now, so we're going to assume a is either 1 or -1. Since the eyebrow is not upside down, we're going to say a is 1. Because we shifted to the left, we'll count how much we shifted to the left. And if you count on your sheet, you should see that you shifted to the left 6. So h is -6. And k, we've shifted down 5. So k is -5. Final equation is going to be this. Y equals the square root of x plus 6, right, minus negative, and then minus 5. If you want, you can put a 1 out front, but you don't have to. And for our last problem, you should notice it's an upside down parabola. Okay, so we know it's a quadratic. So y equals a x minus h squared plus k. Our a value, we're going to assume it's -1. We can't figure out what number other than +1 or -1 is. And then h, we've moved to the right 2 units, so h is 2. And k, we've moved up 3, so k is 3. So now, putting it all together, we're going to have this. Y equals, sorry, I should scroll back up. Y equals negative. We could make it -1, but we don't actually have to write the 1. X minus 2 squared plus 3. And that is how we graph with tables and write equations given h and k or given a graph.